Hello dear students, welcome back to EZEE Notes. Today we'll be starting the part D of this chapter. That is nothing but the last part of the chapter, that is magnifying glass and application of lenses. Okay, so let us see what is a magnifying glass or a simple microscope. See, this is nothing but a magnifying glass. Whenever we want to see any object which is smaller, what do? We use a magnifying glass so that the object seems to be a bit bigger than it is actually. Okay, so let us see. The human eye sees an object distinctly and of maximum size when it is placed at least distance of distinct vision, that is 25 centimeter. See, a human eye have a least distance of distinct vision. What does it mean? See, we can see many objects which is far away, but this is nothing but from our eyes to till 25 centimeter. From eyes to 25 centimeter there is a distance. Till this distance we can see objects clearly. If we bring a bit closer, there will be some stress on our eyes. Okay, it means that to see any object clearly below 25 centimeter, we should have some stress in our eyes. We can't see by relaxed eye. If you want to see by relaxed position of our eyes, so we should place any object at 25 centimeter from our eyes, 25 or more. Okay, to see any object clearly and of maximum size, we should place at 25 centimeter, and that 25 centimeter is known as least distance of distinct vision. Okay, object placed closer to 25 centimeter are not seen clearly. To see clearly, we have to adjust our eyes. Okay, next, the size of the image depends on the angle subtended at the eye. See, here the size is this much. If I take here, it seems to be a bit bigger. If I take far away, it seems to be a bit smaller, right? However, we see it depends on the angle subtended by the eye. If the angle is less than 1 degree, the object is not seen distinctly. Clearly, it won't be seen. To see very small objects, a convex lens of short focal length is used. To see very small objects, we'll use what? A convex lens of short focal length, known as what? Known as simple microscope or a magnifying glass. This is the principle of simple microscope. So the object is placed within the focal length of the lens so that an erect, virtual and magnified image is formed at the distance d from the eye. How does the image is formed? Let us see. See, this is our lens. Which lens? Convex lens. This is optic center and this is focus f1. Okay, so we are keeping an object here, somewhere here, like this here. So what will happen? One ray will pass through f2, right? Then another ray will pass through optic center. If I retrace back these rays, they are meeting at this point. So here there will be an image formed. This image is virtual. Firstly, it is virtual because the rays are not actually meeting, and this image is erect, right? And also compared to object, it is magnified. So this will be the ray diagram. To see any object by using this convex lens, that is nothing but this magnifying glass. If you use this magnifying glass, we can see smaller object of bigger size. We can see the smaller object which will seem to be bigger in size when we use magnifying glass. Okay, so what will be the magnifying power? So magnifying power, maximum magnifying power will be 1 plus d by f, 1 plus d by f, and minimum magnifying power will be d by f. Remember, simple. And what is d? D is the least distance of distinct vision, till where our eyes can see clearly in a relaxed position. And f is what? F is focal length of lens. Okay, so maximum magnification will be 1 plus d by f and minimum magnification will be d by f. Okay, so let us see uses of simple microscope, where it can be used. Firstly, used to read small letters and figures, right? If anything is small, if you use magnifying glass, it seems to be bigger. Next, used by a watchmakers to see small parts and screws. Right, you might have seen watchmakers will put some type of lens here, right? So to see what? To see the small parts in the watch, right? There's many smaller parts in the watch, so it will seem to be bigger in size by using what? By using this simple microscope. Next, using optical instruments like traveling microscope and spectrometer to read the Vernier scale accurately. We have spectrometer, we'll study in class 11. And what is traveling microscope? It is used to see smaller objects in a magnified, which gives a magnified image. Okay, simple. Next, hence it is also called as reading lens. It is also called reading lens. Okay. Next, application of lenses. What are the application? Where are the lenses used? Objective lens of telescope, camera and projector is a convex lens. It is a convex lens and forms a real inverted image. What? Objective lens of telescope, camera which we use now, in which we are recording here, right? That and the projector. These all three have convex lens, which gives which image? Real and inverted image. Next, the eye lens is a convex lens. Eye lens, this one, eye lens, not this one. Okay, eye lens is a convex lens. It forms an inverted image on the retina, which is perceived as upright by brain. Eye lens is a convex lens. Okay, and convex lens always forms an inverted image. But how can we see an erect image? Because our brain does what? It uprights the image. Okay, the image which will be inverted, the brain will upright the image and let us see. Okay. Next, spectacles which we are using, right? Convex lens is used to correct long sightedness, that is hypermetropia. It means that whoever can't see near objects, they use convex lens. Like the old people, right? They'll study like this, right? They use which lens? Convex lens. But like us, okay, concave lens. We use concave lens, who have short sightedness, that is nothing but myopia. If we have myopia, we can't see far objects clearly. We have short sightedness. Near objects can be seen clearly, but the far objects can't be seen clearly. It seems to be blur. So we use which lens? Concave lens to see the objects clearly. Next, bifocal lens are used when both defects are present. If both are the things present, we can't see far objects as well as near objects. So we'll use a bifocal lens, in which what happens? Specs will be like this. See, here it will be like this. This will be used for long sightedness. This will be used for short sightedness. Okay. Next, to differentiate between convex and concave lens. How can we differentiate between convex and concave lens? First thing is by touching. It will look thick at the middle and thin at the edges, which is that convex lens, right? By touching, if it is thin at the edges and thick at the middle, it is nothing but convex lens. If it is ulta, thin at the middle and thick at the edges, that is concave lens. Next, by seeing the image, if we see the image, we can identify which type of lens it is. Letters appears magnified. If letters are magnified, it is convex lens. If letters are diminished, it is concave lens. Letters seems to be smaller, it will be concave lens. Inverted image, convex lens. Upright image, concave lens. Okay. And next some sort of questions we'll do. Name the lens L. Which lens we are using here? Okay. Redraw the complete ray of the diagram showing the formation of the image. Okay. And this L lens is what? Convex lens, because in magnifying glass we are studying about convex lens itself. Yeah, because see, and how we can say it is a convex lens? Because it is converging on focus, right? If it was concave lens, it would have diverged on focus. Simple. So it is convex lens. First one is convex lens. Next, redraw the diagram and complete the ray diagram. Okay, we'll complete the ray diagram here. Another one will go from here. They are meeting here. Our image will be here. Magnified image. Okay, easy. Next, in which optical instruments is this kind of image formed? Simple. Microscope. Simple. Microscope or magnifying glass. Okay, done. Next, A magnifying glass forms a real and diminished image. No, not real, neither diminished, right? Real and magnified image, no. Magnified but not real. Virtual and magnified, yeah. Virtual and magnified image. Virtual and diminished, no, not diminished. Okay, neither real nor diminished. Magnified and virtual image. Next, why are convex lens used as magnifying glass? Why is it used? Because it gives us a virtual, erect and magnified image so that we can see smaller objects clearly, which seems to be bigger in size. Okay, that's why we use convex lens as magnifying glass. Okay, done class? Done. Till here this chapter is completed, so we'll be meeting in the next chapter, that is nothing but spectrum. Okay, till then keep studying and keep following us. Bye bye.